Okay, guys, so this is the last one. So a hive contains 3,500 bees at time t equals 0. So right out of the gate, they are giving us an initial value. I'll say IV, that's an initial value. During the time interval from 0 to 4 hours, bees enter the hive at a rate modeled by this, where EFT is measured in hundreds of bees per hour. Okay, so our units are hundreds of bees per hour. During the same time interval, bees leave the hive at a rate modeled by that, where L of T is measured in hundreds of bees per hour again. Okay, how many bees leave the hive during the time interval 0 to 2? Okay, well, guys, first of all, this is a rate in, rate out problem. So the rate in that they're giving us is E of T, and the rate out is L of T. So guys, we're gonna have to subtract these, like E of T minus L of T, and that's gonna give us the rate of change of the bees in the hive. Okay, so anyway, but that'll come later. So first, how many bees leave the hive? So you're just gonna integrate the rate out. So this will be the integral from 0 to 2. So this is just the net change in the bees that have left. Okay. So minus 2t. Okay, this is a non-calculator section. So I got to do the antiderivative. And these are one steps. Okay, antiderivative. All right. Then I plug in 2. And plug in 0. 26. Now be careful. This is not 26 bees, 2,600 bees have left. Okay, now part B. Write an expression, so that was 2 points. Write an expression involving one or more integrals. So guys, write an expression involving one or more integrals for the total number of bees in hundreds in the hive at time t for this interval. Find the total number of bees in the hive at t equals 4. So guys, we're going to need an accumulation function. That's when they are saying write an expression involving one or more integrals for the total number of bees. We will need an accumulation function. Okay. So guys, let me first define the function for the amount of bees. Okay, so let B of t equal the number of bees in the hive. Okay, now let me think about a derivative sequence. So I've got B, B prime, B double prime. Okay. And guys, B prime, this is important to recognize. This is the rate of change of the bees, and it's going to be E of t minus L of t. All right, this is E of t minus L of t. That's how it always goes for a rate in, rate out problem. All right, now I need to set up an accumulation function. And the way it goes, guys, it's just like the net change theorem, except you're having a t in the top of the integral. So this is equal to B of 0. Okay, we were actually given this. A hive contains 3,500 bees. So guys, they're telling us here that B of 0 is 3,500 bees. All right, so B of 0 is my initial value. And then you add to it the integral from 0 to t. T is the variable. It could be anything from 0 to 4. And now in here, it's going to be b prime of, not t, guys. You can't use the same variable. Here, this needs to be a dummy variable. So they haven't used x, so I'll use x. But you could use any letter. Very nice. Okay, now in the next line, b of t equals 35 plus the integral from 0 to t. And now I'll just tell my reader that. Okay, so guys, this is the first part. Write an expression involving one or more integrals for the total number of b's, and this is it. Okay, this would give the total number of b's in hundreds at any time t that you want. And they're asking for the total number of bees in the hive at t equals 4. So we're going to have to plug in 4 for t. And before I go any further, let me get an expression for E of t minus L of t. Okay, so E of t, this will be like off to the side. E of t minus L of t. And you could do this within the integral, but it's easier for me off to the side. So E of t, 16t minus... Ay! Guys, I messed up already. I'm sorry. These need to be x's. All right, those have to be x's. All right, so E of t minus L of t minus negative 2t. Okay, negative 3t squared plus 18t. Okay, so guys, this is E of t, this is the rate. Okay, this is b prime of t. So I'm going to put this in for the integral here, but I've got to use x's, so I have to be careful. So I've got, I mean, I could do the 4. Yeah, let me rewrite it. All right, now with x's, be careful. Need a dummy variable. Okay, nice. All right, now for b of 4. So guys, I think you'd get credit for having this or this. Either of these are perfectly good for the expression involving one or more integrals, giving the total number of b's. Okay. All right, but now I need b of 4. B of 4, 35 plus the integral from 0. Okay, so 35. All right, these are all one-step anti-derivatives. Okay, so I put the antiderivative in there. And then this is 35 plus, okay, now I plug the 4 in, and I'm getting negative 4 cubed plus 9 times 4 squared minus 15 times 4, and then minus, and you're plugging in 0. Okay, so that's what you get when you do the final value minus the initial value by plugging in these times. Okay, now this is a non-calculator section, so off to the side, you know, do any arithmetic that you need to do. And guys, the reason I wrote it like this is I just wanted to show you that you could treat this like algebra. All right, so we don't need that. So basically, guys, see how the 4 is common, a common factor? So I could take out a 4 out front, and then inside I'd have negative 4 squared plus 9 times 4 minus 15. For me, this is just easier on my brain, you know. So this is 35 plus 4. And then what's going on in here? This is negative 16 plus 36 minus 15. Okay. 35 plus 4. Negative 16 and negative 15 makes negative 31 plus 36. That's 5. Okay. 35 plus 20, 5,500 bees at t equals 4. There we go. And guys, the arithmetic, you didn't have to do it like me, but I just wanted to show you. Algebra moves on numbers, it can be very nice. Okay, so that was 3 points. Excellent. Last part, oh my God, all right. This is 4 points. Find the minimum number of bees in the hive for this time interval. Okay. Guys, min on closed interval. So we need the candidate's test. And guys, if you don't know what I mean when I say those words, you need to know that. What is the candidate's test? When I say that, you should know how it goes. So, because we've been saying it a lot. Anyway, the way that the candidate's test goes is you find the critical, okay, so the critical numbers. So this is where the derivative, so b prime of t equals 0. All right. Now, guys, going back here, I found this is b prime of t. Okay, so this is, all right, that's all b prime of t. So I already found that. So negative 3t squared plus 18t minus 15 equals 0. Okay, so now I gotta solve for that. Take out a negative 3. Okay, and then this factors as t minus 5, t minus 1. So t equals 5 hours, t equals 1. So we're not done. Now, this is the candidate's test, okay? This was the first part. We just found these candidates. And now you take them and you put them in a table. And guys, we're using this closed interval 0 to 4. Okay, so 0 is my first number in the table, and it goes to 4. So which one of these is a candidate? Okay, so this is that's a candidate. And guys, the candidate means like it could be. Okay, this is a potential. So a candidate for this situation would be like a potential time where we might have a minimum. So 1 and then 4. So we're not using 5. Okay. Now, guys, before you go, finding all of these, by hand, make sure that or see if you already have some of these. B of 0. This would be B of 0. That's the initial value that they gave us at the beginning. All right. And, all right, so 3,500. Okay. And then 4, B of 4, they asked us to find in part B. Oh, which I did on this green paper. 5,500. And then for b of 1, I'm going to have to use my accumulation function. So b of 1, so I'm plugging in to this function that I wrote there. It's the same as the net change theorem at this point. 35 plus 0 to 1. Now guys, since this is not a variable up here, it's a number, I don't have to use a dummy variable for the integral. I could still use t's, but since I just indicated that I'm using this formula, I suppose I'll use x's. But it wouldn't be wrong at this point if you use t's, because we don't need a dummy variable. Okay, so 35 plus antiderivative. I actually already did the antiderivative earlier. Okay, 35 plus, right now I'll plug 1 in, negative 1 plus 9 minus 15, and then that's 0 goes in and you just get 0. Okay, so this ends up being 35, and then you add those, it's negative 16 plus 9, which is minus 7. 28. Okay, 2800. Guys, they're asking for the minimum number of bees in the hive. Okay, so it would be this right there. Okay, so I'll say the min number of bees is 2800, or you could go, 2 zeros. 2800, and I'll say at t equals 1. Okay, guys, there it is.